Good evening, everyone. In the last class, we discussed about the basic mathematical tools and we discussed about the integration and the applications of the integration. But in this class, we'll be starting with a different topic, new topic. The topic is the vectors, introduction to vectors. So we'll be giving an introduction, we'll be discussing the introduction or about the vectors. Broadly speaking, we have physical quantities. Physical quantities are broadly divided into two categories. And one of the categories is a scalar and another is vector. In scalar quantities, these are those physical quantities whose direction has no significance. We only talk about the magnitudes of these quantities. Only magnitude is significant, but no direction. But no direction. But in case of vectors, both direction as well as the magnitude is important. Both magnitude as well as direction is important. In case of scalars, we do a normal algebraic addition and subtraction. Suppose we have a speed. Speed is a scalar quantity. Distance is a scalar quantity. In all these quantities, or we can say mass, amount of a substance, it's also a scalar quantity. Length, it's also a scalar quantity. So all these quantities are called as scalars because the direction has no importance for these physical quantities, and they follow normal algebraic addition and subtraction. But in case of vectors, these are all those physical quantities which have both magnitude as well as direction. Both the magnitude as well as direction is important. And they do not follow the normal algebraic addition or subtraction. Like we have 1 plus 1, we say it's 2. 2 plus 1, it's 3. 3 plus 4, it's 7. But in case of vectors, they do not follow the normal algebraic addition or subtraction. What they follow? They follow vector laws of addition and subtraction. They follow vector algebra. They follow vector algebra. For example, we have velocity, it's a vector. Force is a vector. Momentum, it's also a vector. So these are some of the examples of a vector quantity. So in case of all these quantities, velocity, force, momentum, we'll not add all these quantities according to the normal algebraic addition or subtraction. We'll be following the vector laws of addition and subtraction. If any quantity which does not follow the vector laws of addition or subtraction, that quantity cannot be a vector. If any quantity does not follow vector laws of addition, if a quantity is not having a direction, or even if the quantity does not follow the vector laws of addition and subtraction, we can clearly say that the physical quantity is not a vector. So it is important for a vector quantity to not only have direction but also follow the vector laws of addition and subtraction. For a physical quantity to be a vector, it must follow vector laws of addition and subtraction. If any physical quantity fails to follow the vector laws of addition and subtraction, we can clearly say that the physical quantity is not a vector, even if the physical quantity is having a direction. Like in case of current, let's suppose that current of 10 ampere enters this junction. This is a junction here. From this side, and 2 ampere current will enter from this side. Then the amount of current that will be leaving this junction will be nothing. It will be 210 plus 2, that's the 12 ampere. And this is a normal algebraic addition, not the vector addition. So even if the current is having a proper direction here, the current is flowing with a proper direction, but still we cannot call current as a vector. It's a scalar quantity because it does not follow the vector laws of addition or subtraction. So current is not a scalar. Current is not a vector quantity. It's a scalar quantity. So it's important for any vector quantity, for a quantity to be called as vector, to follow the vector laws of addition as well as subtraction. So how do we represent this vector? How do we represent this vector? Representation of a vector. How all these vector quantities are represented. These vector quantities are represented by this length with an arrowhead. Length with an arrowhead, or a line with an arrowhead. So these quantities are represented with line with arrowhead. Line with an arrowhead. So what does this length of this segment represent? This length gives us the magnitude of this vector. This length gives us the magnitude of this vector. And this arrowhead gives us the direction of the vector. Direction of the vector. So greater the length of this segment, greater the length of this representation of this arrowhead line, greater is the magnitude of a vector. Vector of smaller magnitude will have smaller length. Vector of larger magnitude will have larger length. Like this. This is a vector, and this is also a vector, and this is also a vector. Let me call this A, B, and C here. So we can clearly see that the length of the vector A in the case A is greater than in case B than in case C. So we can say magnitude of A vector is greater than magnitude of B vector is greater than the magnitude of C vector. And one more important point is that arrowhead of all these three vectors are directed along the same direction. So we can say that they have the same direction. They have the same direction. So all these three vectors are having same direction, but different magnitudes. All these three vectors are having the same direction, but they are different in magnitude because the length of these vectors are different. The length of vector A is greater than B is greater than C. Let's suppose that what is the symbolic representation? Symbolic representation of a vector is like this. Suppose this is a vector. We give a symbolic representation of this A and put a arrowhead on this symbol A. It means that this represents a vector. This is a representation of vector. So this is how we represent a vector. So length of this vector will tell us about the magnitude of this vector, and arrowhead of this vector will give us the direction of this vector. Let's suppose that this is vector A and this is vector B. This is vector A and this is vector B. So we can clearly say that vector A is not equal to the vector B because direction of both vectors are different. Direction of both vectors is different. And one more point. This is a vector A and this is vector B. Here in the second case also, the direction is same. Direction of A vector and B vector is same. But magnitude of both vectors is different. But magnitude is different. And such vectors whose either the magnitude is different or both magnitude or direction is different or only direction is different. Such vectors we call as unequal vectors. Those vectors are called as unequal vectors. Unequal vectors means either direction or magnitude or both are different. So those vectors whose either the direction or magnitude or both magnitude as well as direction is different, we call those vectors as unequal vectors. Now let's see then what are equal vectors. What are equal vectors? Equal vectors. Suppose this is vector A and this is vector B. Now in this case, direction as well as magnitude is same. Direction as well as magnitude of vectors is same. Direction as well as magnitude of vectors is same. Such vectors we call as equal vectors. So for equal vectors, the two vectors will have same direction. The two vectors will have same direction as well as same magnitude. Such vectors we call as equal vectors. So you can see in this figure, these two vectors are having same length. If they are having same lengths, vector A and vector B, and they are also directed along the same direction, then we can say that these two vectors are equal vectors. Or we can say that vector A is equal to vector B. These two vectors are identical. They are having same direction as well as magnitude. There is one more important property of vector, what we call as shifting property of vector. This is very important. Shifting property of vector. Suppose this is the vector A and it's directed in some random direction like in this figure, in this diagram. If I try to shift this vector parallel to itself, I am not changing the magnitude of this vector, means I will not change the length of this vector. I will just shift this vector parallel to itself anywhere in this space, like this. Or I can shift it here also, like this. Or I can shift it here, like this. I can also shift it here like this. So I'm just shifting this vector parallel to itself. I'm not rotating this vector. I'm not changing the length of this vector. I'm just only shifting this vector with the same length parallel to itself. It means that we can shift vector anywhere in the space parallel to itself without rotating the vector, without changing the length of the vector. The vector does not change. It means that vector remains the same if we shift a vector without changing its length parallel to itself anywhere in the space. Such property, this property we called as shifting property of vector. Means if we shift a vector, anywhere in the space, anywhere in the space, then vector does not change. So we have shift this vector parallel to itself. See, once again, the direction here is also the same. In all the 6 cases, the direction as well as the length of the vector is same. So we can say that the vector has not changed. It is the same vector. So that is very important property. That is one of the important properties of vector that we use uh, in rest of the chapters as well as in the vector also to solve many of the questions of vectors using this property only. That's one important property. Second property is that by rotating a vector by some angle, by rotating a vector through some angle, by rotating a vector through some angle, vector does not remain same, the vector changes. वेक्टर चेंज हो जाता है कि अगर हम हमारे पास स्पेस में एक कोई वेक्टर है, if we try to rotate this vector, even if we do not change the length of this vector, we just rotate this vector. Now what happens because of the rotation? The direction of the vector changes. If the direction of the vector changes, the vector does not remain the same. So for vector to remain same, both the magnitude as well as direction must remain same. So giving a rotation to a vector, the vector does not remain same, vector changes to a new vector. Like this. Suppose I am having a vector here. This is vector A. If I give a small rotation to this vector like this, the vector will become in this direction. Now this vector, I cannot call this vector as vector A because now, because of the rotation, because rotating this vector, even if the magnitude of the vector or the length of this vector remain the same, but now the direction of this vector has changed. Now the vector is directed along some different direction. So I cannot call this vector A. It's a new vector now. It's vector B. So I can say that this vector A is not equal to vector B. So this is the rotation effect of vector. Rotation effect on vector. Rotation effect on vector. So upon rotating a vector through some angle theta, the vector does not remain same. The vector changes because of the change in direction. Because of the change in direction. So these are the two important properties of a vector. One property is we can shift vector anywhere in the space parallel to itself without changing the length or without rotating the vector. The vector does not change, the vector remains the same. But if we shift the vector by giving some rotation, then the vector does not remain the same, vector changes. Let's try to see what are parallel vectors. Parallel vectors. Vectors along the same direction. Vectors having same direction. All those vectors which are having same direction, we call those vectors as parallel vectors. Like this. Suppose this is a vector A and this is a vector B. Does it matter? The magnitude of the two vectors can be different. But if these two vectors are directed along the same direction, we call these vectors as parallel vectors. This is also a parallel vector. This vector A and this vector B. This is also a parallel vector. So all these vectors are called as parallel vectors. So any vector, any two vectors or any three vectors or any n number of vectors will be called as parallel vectors if they are having the same direction. Then what are parallel anti-parallel vectors? Suppose this is the vector A here, and this is the vector B here. This is the vector B. The direction of these two vectors are opposite to each other. Direction vectors is opposite to each other. If the direction of vectors is opposite to each other, even if the magnitude of the two vectors is different, we call those vectors as anti-parallel vectors. Then there is one another kind of vectors that we call as collinear. Collinear vectors. Collinear vectors are vectors along the same line. Vectors or vectors on a same line. Collinear vectors are vectors on a same line. Vectors on a same line. Suppose this is a line and we have vector like this. Let's call this vector A. And we have another vector like this. That's vector B. So these two vectors are collinear as well as parallel. These two vectors are collinear as well as parallel to each other. So they are along the same line, they are on the same line. We call such vectors as collinear vectors. But in this case, the vector A and the vector B is collinear as well as parallel to each other. Let's try to see then another example. Suppose vector A is like this, vector B is like this. So once again, these two vectors are on the same line, but the two vectors are in opposite direction. We can say these two vectors are collinear but anti-parallel. Collinear but anti-parallel or opposite. Collinear but anti-parallel. Another example of vector type of vector are co-initial vectors. Co-initial vectors. Co-initial vectors. Those vectors having the same initial point. Those vectors having same initial point. Call those vectors as co-initial vectors. Like this, suppose we have vector A here and vector B here. And this is the point O. So this point O is the same initial point for both the vectors A and B. Same initial point for both vectors A and B. We can call these two vectors as co-initial vectors, means the starting point of both the vectors is same. Starting point of both the vectors is same. Another type of vector, another definition of vector, what we call as coplanar vectors. Coplanar vectors. Coplanar vectors are vectors in the same plane. In the same plane. Coplanar vectors are vectors in the same plane. Suppose I have vector A here in this direction, and I have another vector B here in this direction. So these two vectors lie in the same plane. These two vectors lie in the same plane. I can call this as coplanar. Coplanar. And two vectors are always planar. If there are two vectors, they are always within the plane. So two vectors are always coplanar. But three vectors, more than two vectors, the vectors can be planar or they cannot be planar. But two vectors are always planar. Suppose we have two vectors, they are in the same plane, but third vector is placed perpendicular to the plane. So we cannot say that all the three vectors are planar. All the three vectors are planar. It's only possible that two vectors are always planar, because if we join the two vectors, we can always pass a plane through the two vectors. So the two vectors are always planar. So coplanar vectors, if there are more than two vectors, three vectors, four vectors, five vectors, it's not necessary that all these vectors will be planar vectors. They can be in two different planes. They can be in uh, n different planes. So it's not necessary for more than two vectors to be in a same plane. So at least the two vectors are always in the same plane. The two vectors are always coplanar. Two vectors are always coplanar. Now let's try to understand what is angle between two vectors. Angle between two vectors. Let's try to understand the angle between two vectors. Let's suppose this is a vector A, and this we call as tail of a vector. Call this as a tail, and this we call as head or tip of a vector. Tip of a vector. If the tails of the two vectors are joined, if tails of the two vectors are joined, like suppose that I am having a vector B here, like this, and the tails of the two vectors are joined, then this angle made by the two vectors upon joining the two tails of the vectors, the smallest angle thus formed upon joining the tails of the two vectors, this is what we call as angle between two vectors. This is angle between two vectors. So angle between two vectors is nothing. It's angle when we join the two tails of the two vectors. Then the angle formed between the two vectors is what we call as angle between the two vectors. Let's try to see different angles of the vectors. Let's suppose that we have two vectors here like this. This is vector A and this is vector B here. These two vectors are along the same direction. We can say that if these two vectors are along the same direction, then the angle between these two vectors is 0 degree. Similarly, if vector A is like this and vector B is like this, opposite to each other, anti-parallel, then the angle between the tails of these two vectors, it's nothing, it's 180 degree. It's 180 degree. And similarly, if one vector is like this and another vector is like this, then how can we find the angle between the two vectors? What we have to do is that we know that we can shift a vector anywhere in the space. Let's shift this vector like here, parallel to itself. We can also shift this vector like here, parallel to itself. So this is our B vector, and we can clearly see that the angle between the two tails of these two vectors is 90 degrees. So this is how we find the angle between the two vectors. We join the two tails of the two vectors, then the smallest angle between them will be the angle between the vectors. Let's see the different cases here. In case A, the example A, we have one vector like this and another vector like this. It's given that this angle is 43 degree. 43 degree. Now we have to find the angle between these two vectors. So what I will do is that I can shift this vector like this parallel to itself. I can also shift this vector. Let me call this A vector. I have shifted this vector like this parallel to itself. I can also shift this B vector parallel to itself like this. So this is B vector. Now we can clearly say that if this is 43 degree, this angle also must be 43 degree, because we know these two angles are vertically opposite angles. So here in this case, the angle between the two vectors is 40 degree, 43 degree. In the second case, these are the two vectors and the tails of these two vectors are joined, making an angle, smallest angle as 30 degree. So we can say that the angle between these two vectors is 30 degree. In the third case is like this, and the two vectors are approaching like this. This is the 45 degree. So what we can do is that we can shift this vector. Let me call this vector A, vector B. If I shift this vector B parallel to itself, it will be shifted like this, right? If this angle is 45 degree, the total angle on a line is 180 degree. This total angle is 180 degree. Then this angle between the two vectors will be nothing. It will be 180 minus 45. So it will come out to be 135 degree. So angle between these two vectors is 135 degree. In the case D, this is the vector and this is another vector like this, and this angle has been given as 120 degree. Can shift this. Let me call this vector A and let me call this vector B here. I know that I can shift this vector parallel to itself anywhere in the space without changing the direction and length of the vector. So this is vector A once again. If this is 120 degree, this complete angle on a line is 180 degrees. So this angle must be then 60 degree. The angle between the two vectors here is 60 degree. In the same manner, if I shift this vector in this direction like this, you can clearly see that the angle theta here is 30 degree. So they are making 30 degree angle. So the angle between the two vectors, that's how we can calculate or find out how we actually define the angle between the two vectors and how we find out the angle between the two different vectors. What we do is that we just try to coincide the tails of the two vectors, then the smallest angle between the two vectors, we call that as angle between the two vectors. So that's it for today. And in the next class, we'll be discussing about the triangle law of vectors or the parallelogram law of vectors, and we'll try to see how do we add two different vectors using the vector law of addition, or how do we find the resultant of the two vectors using the triangle law of vectors and the parallelogram law of vectors. Till then, take care and goodbye.